Okay, 10.2 says logarithms and logarithmic functions. So a logarithm is the inverse of an exponential function. Okay, let's think about that for a second. Remember, our exponential function that we just did was like this. Okay, well, let's think back to doing inverses, chapter 7. How did we find inverses? What did we do? It was a reflection across the line y equals x. What did we do with the x and the y? We switched them, right? We flipped them around. So if I want to find the inverse of this guy, well, then that would be y equals, or x equals b to the y. But remember, I don't like to graph things that are x equals. The only thing that I can graph x equals are sideways parabolas, right? Other than that, I like things to be y equals. So in order for this guy to be y equals, I have to come up with a form for that. So it's of the form x equals b to the y. That becomes from taking the inverse. But in order for us to put that guy out front, we change it and call it a logarithm. So a logarithm is an inverse of an exponential function. I started with my exponential function. I wrote him then. I switched my x and my y. But now I need to write it in a way that's y equals. So to do that, I use the word logarithm. And you're actually going to write the word log. So usually you'll see it as y equals log base b of x. Again, we read it y equals log base b of x. That base is like a subscript. Think about that as a subscript. And then some of you are going to go, that's chemistry, right? No?
Chemistry.
That's why some of you are going to go, ah, right?
Yeah.
Okay. It's okay, these aren't scary. Subscripts aren't scary. Okay? So that little b is a subscript. Okay, so that means we can go between forms. It says log base b of x equals y if and only if b to the y equals x. That's just showing you that we can change forms, okay? We call this logarithmic form. If you see the word log, it's logarithmic form. This guy we call exponential form. Okay, so the first thing we're going to do is just practice changing between those two forms. Because sometimes it's useful. They're useful in their own right. Okay? The thing with writing equations in exponential form. Okay, so these guys right here, number one, I'm giving you to a log form. When you go to exponential form, the equation you write will be true. So, if I were to write this guy, and it didn't make a true statement, I didn't write it correctly. Does that make sense? Okay. Now, let's see where things come from. Notice that the b is the base of the exponent, but b is also the base of the log. Okay, so that's where I'm going to start. The base of the log is 3. So I'm going to start here at 3. 3 to the x, or 3 to the second power, is equal to y, or 9. Did I make a true statement? Yeah, 3 squared is equal to 9.
But y is...
Did I say it backwards?
Weird.
Did I say it backwards? B to the y equals x.
Oh, yeah.
B to the y equals x. I think I said it backwards. Sorry.
Yes.
Okay, so start with your, I also think about going in a circle. Okay, circular form. I'm going to start with my subscript. He's the base of my log, but he's also the base of my exponential. 3 to the second equals 9. Okay, so following that same pattern. Look at B. Start with the base of your logarithm. 10 to the -2 is equal to 1 over 100. Is that true?
Yes.
Yeah, it should be, right? 10 squared is 100. The negative makes it move to the denominator. Okay, so I started in logarithmic form. I went to exponential form. I can start in exponential form and move to logarithmic form. You have to write the word log. Okay, I'm still going to use that same circular motion. All right, so this guy is the base of my exponential, so that 5 is going to be the base of my logarithm. So log base 5 of x, so of 125, is equal to 3. Okay, let's try another one. He's in exponential form. I don't see the log, so log, the base of my exponential is 27, so that's going to be the base of my logarithm. So log base 27 of what? 3 equals 1/3. Okay, questions on changing forms? Like I said, I try to think about it as going in a circle. I say that a lot. Go in a circle. Okay, number 3 there says evaluate log base 3 of 243. Okay, we can do this. Let's just set this guy equal to x. I feel that you guys are more comfortable in exponential form because that's something you're used to, right? So let's change this guy's form so that we can understand what's going on a little bit better. So if my base of my logarithm is 3, the base of my exponential will be 3 as well. Okay, so that means 3 to the x equals 243. Hey, that's what we just did, right? We were just doing ones like that in 10-1. Could I rewrite 243 as a base of 3? Oop, 243. There he is. Yeah, 3 to the 5th. You can also think about it as 3 to what exponent equals 243. 3 to the 5th equals 243. Okay, characteristics of logarithmic functions. Keep in mind that logarithmic functions are inverses of exponentials. Okay, so domains are and ranges get switched. Characteristics of logarithmic functions, it's still continuous. I can draw it without picking up my pencil. There's no holes, there's no asymptotes. Oh, I shouldn't say that. There is an asymptote, right? But there's no holes. There's nothing gaping missing in my graph. Okay, let's go back. On this guy, in my exponentials, the domain was all real numbers, and the ranges were all positives or all negatives. Remember, those are now going to switch. So the domain now are all positive real numbers. The y-axis this time is an asymptote. The range now is the set of all real numbers. And instead of having a y-intercept, we now have an x-intercept of 1, 0. So let me find my, here it is. Nope. Piece of paper. Okay. Here's my exponential. Okay, I'm just going to sketch you an exponential graph. My exponential did this. But now I'm going to flip him across the line y equals x. And my logarithmic functions now do this. Okay. The x-axis was an asymptote for the exponentials. The y-axis is now an asymptote for the logarithmics. This guy never goes negative. Logarithms never go into the negative part of the x-axis. Okay? That means when I look at these guys, my domains are all positives. X is greater than or equal to 0. Or sorry, greater than 0. But my ranges, I have positive and negative values, so I get all reals. This point right here is 0, 1. This point right here is 1, 0. Does that help? A little bit? Okay. All right. Questions so far? Okay, there in the middle of your paper you have a box, and it says these are helpful for solving logarithmic expressions. So the first one you have says log base b of b to the x just equals x. Meaning, if these two numbers are the same, then it just equals the exponent there. Then, if I take b and I raise it to the log base b of x, again, those two cancel each other out and it just equals x. Okay, so look at number 4, a. Log base 9 of 9 squared. I'm raising this guy to that 9 to the what equals 9 squared. 2. So those guys cancel and this guy just equals 2. Does that make sense?
You just convert it. You put equals x.
Here, yeah, let me do that.
9x equals 81.
9 to the 9 squared equals x. Change form. So 9 to the x equals 9 squared.
So why is the 9 like a subscript?
It's the base value. So you'll always have a base value. You'll always have a subscript on the log.
Okay. And so like the 9 that's like after it is the exponent of that 9.
That's what it equals. So this is that guy.
Yeah.
This
just like move it over.
is that guy. So I just changed forms. So this is the logarithmic form. This is the exponential form.
Okay.
So I just changed form so you could see where they came from. But this rule right here says if these two numbers are the same, they're both 9s, it just equals that guy.
Okay.
Is that better? Okay. So look at this guy. This rule says if this number and this number are the same, he just equals x. Okay, so look at 7. I have 7 to the log base 7 of x squared minus 1. Well, those two are the same, so it just equals that guy.
7 log 7 equals x squared minus 1.
Yeah.
So then x equals x squared minus 1, or how do you solve it?
You're not really solving it. We're just saying what he equals. Does that make sense? It would be like, what's 3 squared? 9. Do you see what I'm saying? So we're not really doing a whole lot of solving, even though there's variables there.
Okay.
It's kind of tricky. But on number 5, we're actually going to solve because it says solve. So 8 to the n equals 4/3. But sorry, I forgot the log. Log base 8 of n equals 4/3. Yeah, let's change forms. 8 to the 4/3 equals n. Okay, we did those a long time ago. But if you don't remember, your calculator can do them. Okay? But also remember that when we did these, when we had rational exponents, the denominator was the index. So this is the cube root of 8 raised to the 4th power. Got my chart. Cube root of 8 is 2. 2 to the 4th power is 16. Again, I'm going to show you that on your calculator in case you're not sure. 8 to the 4/3. Yeah, you can. Just be careful if you put in like a negative though. I'll want it as a fraction and not as the decimals. Your calculator probably would give it to you. Yeah. Okay, questions on any of that? Okay, we've got one more page. Okay, so it says to solve logarithmic inequalities, if b is greater than 1, and x is greater than 0, and log base b of x is greater than y, then x is greater than b to the y. Holy cow. That's a little much. And if b is greater than 1, and x is greater than 0, and log base b of x is less than y, then 0 is less than x is less than b to the y bounded by 0. Holy cow, right? Let's do some and let's see if it gets better, because that's a lot of jazz. All right, so number 6 there says solve log base 6 of x is greater than 3. If you notice, both of these guys started out with x. So let's go ahead and put our x with the symbol that they gave us. So x is greater than, and then it looks like they changed forms, which essentially they did. So if I go from logarithmic form to exponential form, this guy would be greater than 6 to the 3rd. So what's 6 to the 3rd? 216. So x is greater than 216. Okay, not bad, right? That's actually that first one. If b is greater than 1, b was greater than 1, b was 6, and x is greater than 0, so we're going to assume he is, x is greater than b to the y. That's what we did. We're good to go. Think about numbers that are bigger than 216, right? 4,598,000. We're good. But on number 7, it says log base 5 of x is less than 2. Okay, we still are going to do this, guy. We're going to do x. We're going to keep the inequality they gave us and change your forms. X is less than 5 squared. So x is less than 25. Okay, give me some numbers that are less than 25. 24.
11.
17. 11.
2.
2.
1.
1.
9.
What else?
Negative 4.
-4, right? -4 is smaller than 25. 0. -839. Okay, well let me look at my graph though, because this is a logarithm. And what do you know about logarithms? They don't go negative.
Then it has to be 0. X is greater than 0, but 25 is greater than 10.
Yeah. So what it's saying up here is that I have to bound it by 0. My graph of my logarithm says I can't go any further than 0.
That makes sense.
So anytime it's a less than, I have to say, whoa, stop. You can get really close to 0, but you can't touch it. Does that make sense? I don't have to do that with the 216 because 216 is going off that way. 216 is getting bigger and bigger and bigger and bigger. But 25, I'm getting smaller and smaller. Ooh, you're getting kind of close, buddy. Don't go any smaller than 0. Okay? So all of this stuff at the top was just a lot of jazz to tell you if it's a greater than, cruise what you're doing. If it's a less than, we have to bound it by 0 because the domain is all positives. Okay? All right. Last thing, and this part is pretty cool. Remember that logarithms are inverses of exponentials. Okay? That means they behave, if you can think about them as behaving like exponents. Okay? Keep that in mind. So, here this first bullet says, log base b of x is equal to log base b of y if and only if x equals y. Well, that's kind of like our rule we had on the very first page that said, oops, sorry, if the bases are same, I can just play with my exponents, right? Okay. Well, the bases are the same. Whoa, sorry. They just have a log with them, so I can just play with my x and my y. That happens for every version of this guy. So if log base b of x is greater than log base b of y, then x is greater than y. And if log base b of x is less than log base b of y, if and only if x is less than y. So if I can get my equation to have one log on each side of the equal sign with the same base, I can get rid of them. Okay, so number 4 here says, log base 4 of x squared is equal to log base 4 of 4x minus 3, and then it also says check your answer. Okay, well based upon this guy up here, if I have one log on each side with the same base, I can ignore it and just work with my exponents, or x squared is equal to 4x minus 3. Okay, what are we going to have to do to solve that guy? Factor. It's your favorite math F word. Put everything on one side of the equal sign. I moved the 4x over and I moved the 3 over.
just did algebra.
Yeah.
And I got weird number.
What'd you do?
I just did algebra.
Oh.
But it was like, I got like plus or minus 4x plus square root, 2x plus square root 3.
Oh. Yeah, we gotta factor that guy. Or I guess you could complete the square if you want. A minus and a minus, or sorry, minus and a plus is a minus and a minus. It multiplies to 3, adds to 4. Okay, now, x minus 1 equals 0, so x equals 3, x equals 1. It said check your answer. Because remember, I'm going to keep going back to my picture here. My logarithms can't go negative. So I can't put a negative number into my logarithm. I can't have a negative base. Okay, so when it says check your answer, it means is the base negative or will any of the numbers that you take the log of be negative? Okay, so if I check 3, well, 3 squared, that would be 9, so that's okay. 4 times 3 is 12, minus 3 would be 9, that's okay. 1 squared is 1, 4 times 1 is 1, minus 3, 1, so they're both okay. So you can have two solutions. You could also have none of them that work. You can have one that works and one that doesn't work. Okay, so number 9. Says solve log base 7 of 2x plus 8 is greater than log base 7 of x plus 5.
So given x squared, we always have to factor from the square, right?
Yes.
Okay.
Yes, perfect, Griffin. Anytime you have an x squared, you're always going to have to factor or complete the square. All right, one log on each side with the same base, so I'm going to say 2x plus 8 is greater than x plus 5. All right, let's subtract the x. So I got 1x plus 8 is greater than 5. X is greater than negative 3. Okay, now let's think about this for a second. Is that okay?
No. Well, yes. Kind of.
Kinda.
Because it can't be negative.
It can't be negative, but when I plug it in, am I taking the log of a negative number?
No.
No, it has to be okay, right? So think about things that are bigger than negative 3. Let's try negative 2. If I plug a negative 2 in, 2 times negative 2 is a negative 4, plus 8 is positive 4, so that's okay.
-2 or 5 is positive.
Positive 2. So it's okay for our answer to be negative as long as it doesn't make you take the log of a negative number. Okay, are there any questions on anything we talked about? Okay, let's look at your worksheet then.
Do you have a log button on our calculator?
You do have a log button on your calculator. We're going to talk about that in 10.4, I believe. It's a base of 10. Yes. So there is a, if you see the log button on your calculator, good question. So there's a log button right there. It's a base of 10.
Oh, I see.
Yeah. Okay, show your worksheet. Your worksheet, the first 4, you are just changing forms. You don't have to solve anything, you don't have to do anything, you're just changing forms. So you're going to write it with the word log. 5 through 8, you're going the other way. You're just going to write it as an exponential. You're not going to solve anything, you're just rewriting it. So take the word log out and write it as an exponent. Number 9, there's lots of ways to do these ones. If you want a chart, go get more copies of the chart out. You can have a chart. Okay? Remember, you've got some rules to help you in this box. Do you want me to do one, JJ?
Can you just do the first one?
Like number 9? Or number 1?
No, number 1.
You bet. Okay, so it says write it in logarithmic form. So I need to write it with the word log. So I'm going to say log. The base of my exponential is 2, so that's going to be the base of my logarithm. You're welcome.
And the exponent of the 2 would be what it's set equal to?
Yes. So log base 2 of 8 equals 3.
Got it.
Do you want me to do like 5 then?
Sure.
Okay, so let's do the other way. So now in 5, you're going to be writing it without the word log, and remember it will be a true statement. So the base of my log is the base of my exponential, so 3 to the 5th equals 243. Okay, you don't have to do anything else, you're just rewriting them.
Got it.
Okay. 9 through 16. There's lots of ways to do those, guys. You do have 2 rules. Log base b of b to the x equals x. B to the log base b of x equals x. So those are your 2 rules. So you can use those. They can go super fast if you want. You can also set them equal to 0 and change forms, whatever you're comfortable doing.
So I also have a question.
Yes, Pilar to both.
So if they're like opposites of each other, like they're inverses, how can we like make them equal to each
What do you mean?
other? Like because like for instance number 5,
Okay.
3 to the 5th equals 243 equals
Um,
log 3.
So think about them as it's just a different way of writing it. Okay, so they're exactly the same thing. It's just a different way of writing it. So this guy, we would call that in exponential form. Think about when we were doing like parabolas, right? Or circles and hyperbolas. We would put it in the standard form so we could see where the vertex is or the center or whatever. But it was also the same the way that it was all written out. Does that make sense? So think about it as like 2 different forms of the exact same thing.
Like, yeah, but then there's the, like, how you graph it and how exponential things has to stay above. Yeah, that.
Right.
Like,
So,
if they're the same, then why are they, like, different?
so if I were to graph a logarithmic one, it would still be the inverse. It's not the same equation now. So these 2 have 2 different equations to them. This is just writing that equation in 2 different ways. So think about, I can write this equation as y equals x. I could also say he's x equals y. Does that make sense? So that graph doesn't change. This graph does change. So this would be like y equals b to the x. This guy is x equals b to the y. So they are 2 different equations because they're inverses.
Got it.
But in order to write this guy so that I could graph him, I can write it like this.
Oh, okay.
Does that make better sense?
Yeah.
Yeah. So these 2 are 2 different equations. These 2 are not.
Okay.
They're the same. I shouldn't say that. They're different forms of the same equation.
Okay.
Okay, good question. Glad we cleared that up.
And because, like, this is all logarithms, but you're just writing logarithms
In a more comfortable form, I would
Yeah.
say.
Okay.
Yeah, because I feel like exponentials, I mean, you've been doing, this is the first time probably ever you've seen an exponent that's a variable. So think about math. You know, your whole life they've never been that way. Yeah. Okay. So 9 through 16, you're just solving. You should get some sort of number there. 17 through 26, you're solving those, guys. If you have one log on each side, they can cancel. If not, you need to change forms and write it as an exponential. But you have to check them. Okay? Okay. Pilar asked if we could do 22. You bet. All right. I don't have one log on both sides with the same base, so I can't get rid of it. But what I can do is then change forms. So if I change forms, b to the 1/2 is equal to 3. Remember that to the 1/2 power also means the square root of b equals 3. How do I undo things that are square rooted?
Square that.
You square them. So in this case, b would be equal to 9. And 9 is an okay base for me to have. Good question.
Why do you get square root of b?
So we got b to the 1/2. So when I changed forms, I got b to the 1/2 is equal to 3.
Yeah.
So remember, 1/2 is the same thing as taking the square root.
Okay.
Right. Make square both.
So then I have to square both to undo that square root.